Hi everybody, we're going to do some practice test review. You need to quickly take out a piece of paper, and that paper you're going to fold in half, and on the front you'll write the title Linear Functions. You'll put your name right here, your name. The title on the front cover will be Is It a Function and Word Problems. And then when you turn your paper over, you'll split it into two sections and you'll have a title, Write an Equation from a Graph, and Parallel and Perpendicular. So again, this is one sheet of paper. The front will have a section that says, Is it a function and word problems? And the back will have a section that says, Write an equation from a graph and parallel and perpendicular. Quickly get that ready, and when you're ready to proceed, go ahead and unpause the video. In our first section, I'm asking the question, is it a function? I'd like you to take a moment to copy down all four of these problems. So for number 1, you have a coordinate plane with a squiggly graph. In question 2, you have a table with 4 points. Question 3, you have a list of 3 points. In question 4, you have a graph with another, a coordinate plane with another red graph. Go ahead and copy those down, and then we'll talk about whether or not they're functions. Okay, so you should have copied down all 4 of your problems. The first question gives you a coordinate plane, in which I would hope you would remember the vertical line test. The vertical line test says that if I can draw a vertical line and it only crosses the graph once, excuse me, then it is a function. So in this case, with my vertical line, it only crossed the red graph once, so this is a function because it passes the vertical line test. For question 2, they've given me a table. In this case, I want to remind you that we check to see if it's a function by looking only at the x values. Remember, the definition of a function is that every x value has a unique y value. Now, if there's any x values repeated, then that means there's an x value with a different y value. That's what makes this not a function, because there are 2 3s, one goes to 12 and the other one goes to 5. That's why this is not a function. For question 3, I have my domain is 1, 3, and 2, and my range, I'm recognizing this looks like a point. That's supposed to be a comma, guys. That's a comma. And your range is 3, 5, and 5. So here's where we check. Are there any repeated values in my domain? I have a 1, a 3, and a 2. There's no repeated values. That means this is a function. And last but not least, for number 4, since they gave me a graph, I'll go ahead and do the vertical line test. It's crossing my red graph twice. That means this is not a function. Now let's look at word problems. For this section, you don't have to copy down this entire graph, but I do want you to take a minute while I'm talking to copy down the table. So you should be copying this down while I read the problem aloud. Question 3. The data in the table shows the cost of video games by the hour, including a deposit. So for renting a video game, here's a table of some of those costs. If I rented one for 2 days, the cost would be $25. For 3 days, it would be $35, and for 4 days, it would be $45. They're asking me to write an equation in slope-intercept form, okay, where C represents the cost and D represents the number of days. Okay, so if I'm going to write it in slope-intercept form, I need to know what M is, and I need to know what the y-intercept is. To find the slope, we know how to do this. We're going to examine the change in y. In this case, each time the change is going up by 10. And my change in x, which each case it's going up by 1. So now we can formally say, okay, the slope of this equation is going to be 10 over 1. $10 for every 1 day. Now the second thing I need to find is my y-intercept. Now when I look at this table, I don't see the y-intercept. Remember, the y-intercept is a point where the x value is 0, and then our b value goes there. Now, since I don't know what my b value is from the table, I have two choices. I could manipulate the table using the slope, or I could use one of these points and this slope to write the equation in point-slope form. So let's move this out of the way just a little bit. All right, I'm going to pick my favorite point. My favorite point is 225. 225 is my favorite point. That will be my x sub 1 and my y sub 1. All right, I'm ready to write in point-slope form. Y minus y sub 1 equals my slope times x minus x sub 1. Now, this right here is my equation in point-slope form. But they asked for my equation in slope-intercept form. If they just said write an equation, this would have been enough. But they said write an equation in slope-intercept form. So I have no choice but to distribute first. I would get y minus 25 equals 10x minus 20. This is almost slope-intercept. I'm going to add 25 to both sides. And I get y equals 10x plus 5. So the equation for this line in slope-intercept form, slope-intercept form, is y equals 10x plus 5. Now for this next question, I don't want you to try to copy down this graph, but I do want you to take a moment to examine it. So I'm going to ask that you pause the video in a moment and that you try to find the equation of both of these lines just by looking at the graph. Now notice there are two lines here, so you're going to have to find the equation of the line for this blue line, and then after that this red line. And write your work down here and what you found. Go ahead and label, like if you found the slope, what's the slope, and then the equation that you chose. And then unpause the video and we'll go over it. Okay, so let's see how you did. I'm going to start with the red line. When I look at this red line, the first thing I notice is that it crosses the y-axis at -5. What's this point called, guys? That's the y-intercept. And we call the y-intercept B. Now remember, the location of this point is 0, -5. That means that for the red line, my y-intercept B is 0, -5. Now if I want to write this in slope-intercept form, I'm almost there. I just need my slope. Now when I look at this line, I automatically see that it's increasing. That means the slope is positive. So I'm going to need to pick out some good points. So let's see. I'm going to go ahead and pick my y-intercept point, and I'm going to choose the x-intercept as my other point. So the question is, how much did I rise and how much did I run? Looks like 1, 2, 3, 4, 5. Looks like I rose 5 and I ran 1, 2, 3. That would mean my slope is 5/3. So if I wanted to write an equation of the line, it would be y equals 5/3x minus 5. I hope you got that right. Okay, let's try the blue line. So I'm going to trace my blue line, see if I can find my y-intercept. Ah, there it is. Right there is my y-intercept. My y-intercept is at the point 0, +5. And now to find my slope, I'll need to find another good point. I like this point right here. So what's the change here? Well, I can tell this line is decreasing, so I'm going to have a negative slope. Falling 1, and running 1, 2, 3, 4, 5, 6. That means my slope is negative 1 over 6. Or my equation is y equals negative 1 over 6x plus 5. And that's how you find the equation of a line from a graph. Now to your favorite questions of all. Parallel and perpendicular lines. Now I am going to give you a second to copy these 3 questions down in the parallel and perpendicular lines section. Go ahead and take a moment and copy them down as I'm reading them to you, and then we'll unpause the video and go through them. The first thing I ask is for you to write the equation of a line. Write the equation of a line that is parallel to 2x plus 6y equals negative 18. Write the equation of a line that is parallel to 2x plus 6y equals negative 18. The second part of this question says write an equation of a line that is perpendicular. Write an equation of a line that's perpendicular to 2x plus 6y equals negative 18. The last question says write the equation of a line that is parallel to 2x plus 6y equals negative 18 and passes through the point negative 1, 2. Now, I'm going to go ahead and ask you to pause the video if you're not ready yet, and when you are, unpause it and we'll go over all these questions. The first thing I really hope you noticed is that all 3 of these questions are talking about the same line. But in each case, they're asking us to find a line that's parallel, or perpendicular, or parallel that goes through a certain point. That's what makes our first question different from our second question, different from our third question. Now, in order to write an equation of a line, let's say that's parallel, I need to find the slope of this line first. So to do that, we're going to need to take this equation and put it in slope-intercept form. So let's do that. Let's subtract 2x from both sides. That'll get us so that we have the y term alone on the left, and I get negative 2x minus 18 on the right. Then let's divide by 6 all the way around, and when I do, I get y equals negative 1/3 x minus 3. So this is the equation in slope-intercept form. And I got the negative 1/3 by reducing negative 2 over 6, and I got the negative 3 by dividing negative 18 by 6. Now remember, my purpose in doing this was to identify the slope. And that's when I found that the slope was negative 1/3. So if I want to write a line that's parallel, it'll have the same slope. So let's write a line. The equation of a line is y equals negative 1/3 x plus, pick a number, guys, any number. Pick a number different from somebody at your table and put it in there. Someone put down a 2, put down a 3. Someone put down a 3, put down a 7. Someone put down a 7, put down negative 3.14. The number that you put in here really doesn't matter as long as it isn't negative 3. This is the only number that's off limits, because if you chose negative 3, well, you would have written the exact same line, and the same line isn't parallel. If you want to write a line that's parallel, it should have the same slope, but a different y-intercept. Now, once you've done all of this work for this first problem, the second equation's really easy. If I want to write an equation that's perpendicular to this same line, here's what I know. The slope of my old line was negative 1 over 3. That's the line we've been talking about. So if I want to write a perpendicular line, then I know that my new slope should be the opposite sign, and it should be the reciprocal to my original slope. Reciprocal. So let's do opposite signs. So that means in my new line, the slope will be, well, not negative, it will be positive, and not 1 over 3, but 3 over 1. So if I want to write the equation that's perpendicular, it would just be y equals 3x plus, well, name your number. As long as your slope is opposite reciprocal to the original, so this slope is opposite reciprocal, then the equation you write, as if it has the opposite reciprocal slope, then any number you put in for the y-intercept will create a line that is perpendicular. So we have our parallel equation and our perpendicular equation. Obviously, you need to put a number in where the number is, right? Okay, now for our last question. Now, this is the one that's going to require a few extra steps. It asked us to write the equation of a line that's parallel, so I've done that before up here, but this time they say it has to pass through the point -1, 2. You know what, if this point had been the y-intercept, I would have just put that number here. But this is a general point. This is not the y-intercept. So we're going to have to take that point, -1, 2, and the slope of -1/3. And I note that I chose -1/3 because they said parallel. And I'm going to use point slope form. So here's my x sub 1 and my y sub 1. And I get y minus y sub 1 equals m times x minus x sub 1. Look what happened here, minus x sub 1. I've got two negatives, so you need to address that. What will that x minus minus become? Become x plus 1. Well, let's check this out. Is this line parallel to our original line? Same slope? Yes. Does it go through the point -1, 2? Yes. There's the equation of a line that's parallel and passes through the point -1, 2. Guys, I wish you lots of luck on your test. You're going to do fantastic today. Please remember to be absolutely silent. I do not want any tests taken away today. Do your very, very best. You're going to do fantastic. I believe in you guys. Good luck. Bye.